All right, so tell me what we've been doing aside from graphing. What has the whole rest of chapter 1 been focused on? Finding your x, so solving a quadratic. So tell me some ways we've done that. Factoring and solving.
Perfect square trinomials.
Perfect square trinomials, so completing the square, solving.
And all the forms.
All the, yeah, like the vertex form.
Okay. SAD mapping, we've done that too, right? So now we've come to the point where maybe complete the square can be done on any quadratic. Okay, that's not stipulated. Not everything can be factored, not everything can be SAD mapped. So the problem is some complete the squares can get a little, as we've seen, right? Especially when that B, depending on what that B is and what's left, it can get really pretty sticky. So we have the quadratic formula. And what the quadratic formula does, if my pen will work, is it solves any quadratic for us that's equal to 0. Okay? That's the key. It has to equal 0 first. To equal 0 before you start. Okay? Now remember, if B is not there, B is 0. If C is not there, C is 0. But the quadratic formula, and this actually comes from if I took this and completed the square with the variables. I can show you if you want to, but I won't do it in class. It's pretty fun. But if you moved that C over and then you did B over 2 squared and then you factored, but you left it with variables and did it, you'd come up with the quadratic formula. So I'm going to just give you the quadratic formula. It's opposite B, and yes, you have to memorize this formula, but that's part of your extra credit project you're going to have. Yes. Yes.
Don't we get harder?
Yes. I'm going to talk to you about it just a second. Opposite B plus or minus the square root of B squared minus 4AC all over 2A. Okay? I promise you, whenever you finish with your project and you finish doing probably half of your homework, you will have it memorized.
So we've got that. We'll give us the question. We'll just put the...
I'll say solve using the quadratic formula. This one doesn't have any restrictions. Your leading coefficient can be positive, negative. You can have a leading coefficient. The only thing is it has to equal 0. Okay? So let's do one. Let me show you how it works.
So we'll give you 2 different answers because it's possible minus.
You're exactly right. That's where your 2 answers come in. So even ones that can be factored, you can always use this formula. The reason we don't is sometimes some problems, if you can factor it and solve it, why wouldn't you? That's so much easier than this. But this lends itself to any problem, which is why we have it. All right, so let me show you an example. Let's do x squared equals 6x minus 4. Actually, I'm going to go to a new page. So x squared equals 6x minus 4. Now, what did I tell you before? You could use, it has to be equal to 0. Okay? Now, just out of habit, I'm going to move the 6x and the negative 4 because that's what I'm used to doing. But if you move the x squared, that's fine too. So I'm going to minus 6x and plus 4 to make it equal 0. It may be helpful if you write your A, your B, and your C out before you start, since you're just plugging in that formula. So if you look at this, what is A? 1. What is B?
6.
Negative 6. What is C? 4. All right, so I've got, well, just copy that formula down. Plus
So
or
the
minus.
x's and the squares just tell you which one it is?
Yes, tell you which term it is.
Ooh.
All right, so let's plug in what we know. All right, B is negative 6, so opposite B would be 6 plus or minus the square root of. I've got negative 6 squared minus 4 times A times C all over 2A. So anybody have questions about how I plug that in? This is literally plug and chug. Yep.
Wait, so if it's plus or minus, then it makes it be the opposite?
Do what?
When it's plus or minus.
The plus or minus, that's giving me my two answers I need.
So it just tells you to put it in the opposite.
The negative in front of the B tells you to do the opposite of B. In the very front. This really, you could split it up. You could say opposite B plus the square root of B squared minus 4AC over 2A. And you could say opposite B minus square root of B squared minus 4AC all over 2A. It's just telling you there's two answers. It's the plus or the minus. All right, so I'm going to look under the radical first because you always want to simplify under the radical first. So I've got 36 minus 16 over 2. I'm going to have to come this way a little bit. 36 minus 16 is 20. You can break 20 down, 4 and 5. So 2 root 5, that's right. Take a 2 out of everybody. 3 plus or minus the square root of 5.
Pretty easy.
It is.
I'll do it on the board.
All right, one to practice, one to practice. Let's see.
Yeah, let Robert do it. Let him do it with the board. Robert versus Bobby.
Let's go through it together so you can check what you got. All right, opposite B plus minus square root of B. Is this not the one we did before?
It's very similar.
Oh my goodness, I apologize. Minus 4 times A times C. Now I will tell you be careful if A or C are negative and watch your signs because minus a negative is plus a positive, right? All right, over 2A.
What else is there? I forgot about. Went all the way through, but I forgot.
All right, 36 minus 40 over 2. So 6 plus or minus the square root of 4, negative 4 over 2. Uh-oh. I got an I. But I can leave it the I, or I can take a 2 out of everything, simplify it. So I get 3 plus or minus I.
Wait, I had negative. Oh, no, I didn't. Never mind.
I want you to notice something. Here, I have 2 imaginary solutions. Do you agree with that? So that means we've been talking a lot about our parabolas and our intercepts and what that means. Tell me what that means.
It doesn't cross the
It doesn't cross the intercepts. It looks like that or like this. It doesn't cross the x-axis anywhere, right? They're imaginary solutions. I want you to think about that. I also want you to look back at the first one we did, and we had how many solutions here? 2, but they're real number solutions, right? This crosses 2 tangible places on the x, so 2 real solutions here. Tell me what's the difference? What's causing in this equation, this formula, what's causing me to have 2 real versus 2 imaginary? There's a negative square root. You're absolutely right. That's a great connection. We call what's under the square root the discriminant. No, it's not bad. The discriminant is simply that little piece that's under the radical, okay? So we can get more information about what this graph looks like without actually graphing it by just analyzing this part. Because we know if we do this and we get a negative number, what does that mean about my graph? It has imaginary solutions. It has 2, in fact, imaginary solutions. Imaginary solutions. We also know if it's positive, what happens? They exist. Real numbers, how many? 2. Can you think of any other scenario besides positive or negative that might occur under that radical that might tell me?
Zero.
0. What happens with 0?
It's, yeah, on the axis of it.
It's on, so how many solutions?
1.
1. That vertex sits on the axis. Good job, guys. So you'll be asked on your homework and your tests to classify the number and type of solutions based on the discriminant, okay? And that just means we're going to plug in here. If we get a negative number, there's 2 imaginary solutions. If we get a positive number, there's 2 real solutions. And if we get 0, there's 1 real solution. Does that make sense? Example? An example real quick. 8x squared equals 9x minus 11. This time I don't want to know what the solutions are. I just want to know what kind I will get. So you still got the equal 0 because it's still a part of the quadratic formula, right? That's right. So let's do b squared minus 4ac. Negative 9 squared minus 4 times a times c. Negative 9 squared is what?
81.
81? Oh.
It's going to be 2 imaginary numbers.
I don't, yeah. And in fact, you don't have to take it all the way out. I can look at that right now and know that number's going to be bigger than 81, right? So this is going to be a negative, so it's going to be 2 imaginary. But what is 4 times 8 times 11? 4 times 8 is 30. What is it? 352? So when I subtract these 2, I get a negative number, which tells me 2 imaginary solutions.
260 something.